So I'll begin by introducing Women Who Code, and then we'll let Iryna lead the rest of the session. So we're here for coding in Corda with beginners today. Myself and Sapphire are the co-leads on this track. You can always reach me at naomi@womenwhocode.com if you have any questions, if you want to volunteer, if you've got ideas for speakers or topics you want to cover. We do have a variety of other folks working with us. Our track leads are being updated before September, but this is an idea of kind of who's working with us to make these webinars happen, keep everything running. Our mission here at Women Who Code is inspiring women to excel in technology careers. And our vision is a world where women are representative as technical execs, founders, VCs, board members, software engineers. Wherever you find people in technology, we want to see women there. We have 230,000 members right now, 70 networks across 20 countries. If you go to womenwhocode.com, you can find our job boards, resources, scholarships, all of those kinds of things. Our movement is, as the world changes, we can be a connecting force here at Women Who Code to create a sense of belonging while the world is being asked to isolate. So please feel free to connect with each other in chat. We'd love for you to make some new friends here too. We do have a code of conduct. Women Who Code is an inclusive community. If there's anything that kind of, isn't so comfortable for you, womenwhocode.com/code of conduct, you can send reports there. We do have a variety of other track communities, so you can check out cloud, mobile, data science, again, womenwhocode.com, and check out the events. You can join our blockchain track. We are looking for speakers. We're looking for volunteers. Just send me an email, naomi@womenwhocode.com. And then I'll just let Iryna take it from here. This is a series of study group workshops. So this is the third or fourth in the series now, Iryna, yes?
Hello, everyone. Yes, it's the fourth lecture. And thank you very much for coming. And so I'm just will share my screen in a second. Okay. Can you see my screen?
Yep, it's looking good.
Okay, thank you. So again, hello everyone. Welcome to our interactive learning sessions of Corda 101. And this is the first interactive session. I'm Iryna from R3, a company who designed and developed Corda, the distributed ledger technology. And I'm leading this session today. And Corda platform is really hard, and we're developing this series of educational pieces for people on Corda. But the important thing is really I want to get your feedback from whether the way of me explaining is useful for you. In these interactive learning sessions, which last for 1 hour, there will be a specific period when I will be reaching out to you, everyone, and asking you your feedback on each block of concept that I'm providing. So basically, you understand or no, your comprehension on it. And if I explained it well, so I just want to make sure that I explain it well. I don't want to judge you, I want you to judge me. And I will, if something is not, like if I see that someone is not struggling with some of the pieces, I will just reiterate it again. We'll try to explain differently. So halfway through, I'm going to stop for 5 minutes and I'll put an anonymous Google survey for you to give me more feedback. There is in total, I think, like 8 sessions. This is the 4th session. After which, after we finish with our sessions, we will provide you with a free Corda certification exam for people who have attended all of our sessions. And usually this Corda certification exam costs like $150. So we're giving it for free here. So please stay tuned, give us your feedback, and together we'll get Corda certified for free. So I just wanted to ask you, everyone, where you from today. So just wanted to know where our audience are from. I'm just like now in London, and yeah, if you could type in the chat where you guys came from, so we know where our main audience is. So we will advertise and promote more in your area. And I will provide later for the links to the previous sessions and to the exams, to the examples as well. So let's begin. So you can also find us on Slack. Here you can find Corda documentations. This is our GitHub repository, and this is how you can contact us. If you contact me if you have any questions. So for today, today's sessions, the main aim to look at the persistence data on ledger and off ledger. So we know that Corda is distributed ledger technology, which is basically a database, and it's very secure, and it provides the main functionality is when two parties communicate, and they store automatically the message that they communicated on the ledger, and the main property of the ledger is you see is what I see. So if, for example, Alice and Bob communicated a message, then this will be for sure on the ledger stored the same message. So we'll go through example, and later I will show persistence of ledger, which means that we will just create custom schemas. This is in case if we need to integrate our systems and get query data faster, and if we don't care about security, because since on ledger data is secured, it's also stored in binary format, so we cannot just open table and read it as it's in normal schema. So I will show you how we can store data, our states on ledger, and then additionally to it off ledger, and how we can query it. But before that, we need to go through transactions. We need to understand what is transaction is and what is contract is. So we all know, we all heard about these definitions, transaction and contract. Just to show, I will show you a quick example of transactions and contracts on Corda, how it basically works. We all know contracts, but how is it in digital representation of it? So let's move on. So we have, let me show. So we have this example. So ledger is updated using transactions. And we also learn what is state on our previous sessions. So state is basically a piece of data that is stored on parties who've been involved in this communication. And state is immutable. So if Ali sends a message to Bob, says, "Hi, Bob," and Bob receives this message, he cannot change it. So the only way to, if, for example, we use it for, in some cases, we don't need to change it, right? For example, if it's a message, if it's just a message. But if it's asset, right? If I put, if I have a car, for example, and for this car I also have some details, like who is owner, details of the car, and other information. So the only way for me to change this state, which is a car, is to update it by means of transactions. So I'm basically, I put into transaction as input my current state. So put my current state, and then as an output, I put updated state with the fields that I wanted to change. Right, so I change a state that is immutable by by running transaction on this state, and updating the output of in the transaction would be a state that I would like I would like to change. So let's see on this example. For example, two parties want to transact, and one party wants to sell a car to another party. And so the transaction will be input where owner is a Titan, and the output owner is Acme. So previously, Titan had a transaction, and this will be marked as old transaction, like a historic transaction, and the new transaction with updated fields in the message, in the state, will be a new one. And the same for Acme. It didn't have any information about this car before, but now it has a new state, and these both states will be the same. And after that, all previous information about all old states will be marked as historic. So this is in most use cases, in Corda, you already have a state, and you want to when you consume one state. So when I say consume, the input is one state, and produce output the new state, and then mark all state consumed one as historic. So the transactions is a means for us to change the state, to change any fields in the state, any information on the state, because state by itself is immutable. You cannot change it. Once it's in Corda, once it's there, you cannot change it. Do you have any questions so far? Let me see the chart. So hello, Asim and Natalie, and Natalie is in Reading, by the way, and Asim is from Kuwait. Wow, that's impressive. Yeah, guys, do you have any more questions so far? If not, I will proceed. So yeah, if you want, so let's go to the contract. And also what I wanted to, so now let's go through our contracts. So you have a state, and you can do transaction to update your state. But you cannot update your state randomly, right? Like, for example, in this example, when Titan and Acme are using, when Acme is buying car from Titan, it cannot just like change it. You need some business rules to follow while you update your transaction. And you have for these purposes, you have a contract to validate your transaction. Contract has some business rules, and contract run on multiple nodes, on each node differently. So the same transaction, everyone has a contract, each parties, and only when this transaction run through contract and it's verified, then transaction is approved. So for example of a contract, I can have like Alice and Bob, and Alice transfers money to Bob, and this amount is $3, for example. And here is examples of contract verification, like checks if transaction is valid. So it checks if this transaction in general has one input and one output. Yes, it is. If a transaction has a transfer command, yes. If cash in equals to cash out, yes. And then if input cash owner is required to sign this transaction, yes, it did sign. So only then transaction is valid. In another example, so we check if transaction has one cash input and one cash output. Yes, that's true. It has a cash transferred command. If cash input equal to cash output. No, someone tries to issue themselves the money, so this transaction will be rejected. So I'm going through example with you today of persistence data on the ledger and off ledger, and I'll do a demo how we can assess it and how we can get into the persistence of the data. So mainly, let me start with a product state, which is open here. And so as we saw previously, every state is implemented of the contract state, and which is required to be persistent required to be persistent in a custom database table, must be implemented as a queryable table. So I will also want to state that one state can be mapped to multiple schemas, and state is always stored on the ledger. And if you want to map your state to custom schemas, then you need to add it as a queryable state. And our state has list of parameters that describes it. For example, product has SKU, name, detail ID, and so on and so forth. And a queryable state defines below two methods, which must be defined by a class implementing the interface. So this class needs to implement these two methods, support schema and generate mapped object. I will talk a bit later about implementation of it. For now, let's skip it. So for now, we just need to, in order to store data we need to we need to create a state which implements contract state to signal Corda that this class is a state, and if we want to query this this state from custom schemas, we need also make it subclass of queryable state and implement supported schema and generated object. So a queryable schema, queryable state mandates the state to provide list of schema it would need to support, and the supported schemas are returned as a mapped schema, and objects from supported schemas, which is we have. Over here. So we have our schemas that are stored off ledger here. And it extends from a mapped schema. Corda node runs a service called schema service, which is responsible for generating persistent state. This persistent state. Object corresponding to queryable state by calling generate mapped object. And the persistent state is then handled to the ORM tool for persistent state in the database tables. So let's see how we can implement this queryable state, which means we can query it off ledger in a simple, like 5 steps way. So first of all, we need to create queryable state. Here again. So it's defined as regular contract state in Corda. It implements the queryable state interface instead of contract state interface. And we need to provide the implementation of these 2 methods. Generate mapped schema and get supported schemas. Step 2, we need to create this entity, which is a subclass of persistent state, which is in our case is persistent product. And for this to make sure that we need to annotate it with the entity table and give a name of this table, which is product. And we need to put columns that we want to store. So this persistent product corresponding to the state with all the fields required to be persistent to the database. As we saw previously, here here we have way more fields in the class, but we only want to store in our off ledger, like normal schema, like database table, only 2 fields. So then the ORM tool would use this entity to store the data on the custom table whenever the new state is issued. So our ORM tool is a object-related mapping. It's a technique for converting data between incompatible type systems. So few points I want to note here, that the class has to be extended persistent state. This ensures that these fields of the state appears in the database table. And if we don't provide IDs, then attributes of these 2 fields would be used as a composite primary key in the custom database table. And we also need to provide a default constructor, since it's required by our system. So we need to create, the next step is we need to create a schema family. This is our superclass, and then we call it from our schema.sort_of_ledger here, and this should be associated, so our mapped schema has to be associated with this superclass, which is consistent across versions of the schema. And this allows the schema service to select the appropriate version of the schema if it has evolved over time. Because here now we have only first version, if it changes later, we will put our product schema v2 instead of v1 and use the same constructor and put here the version in the another schema version 2. And in this case, the system will understand that the version is updated. So next step for us is we need to create the mapped schema. So this mapped schema subclass, which represents the schema that would be supported by the queryable state. So we need to provide this schema family, the version of the list, and corresponding to the list of all persistent states that we want to persist as a list. Now let's move back to the product state and implement and look at the implementation of supported schema and generate map schema object. So as I mentioned above, the supported schema returns a list of map schema object that's supported by queryable state. And in this case, we need to return an instance of product schema v1. So we create a new product schema v1. Which is a subclass of a map schema. So if I press here, this is a subclass of a map schema. And then at step 6, I need to implement generate mapped object. This is where we define the logic to generate the persistent representation of the state. The persistent representation is our entity that we defined earlier. So our product schema v1 entity, and we create this representation here. So now I would like to ask you to fill quickly the questionnaire that I created, and I will just send a link to it in the chat. So please, could you please fill it for me to understand if you are guys following me, or I need to go over some things again. I will wait for a couple of minutes, so don't worry. So Arijit is asking, where can I get previous recordings? One recording was on YouTube. Naomi, is it correct, right? You're uploading them on YouTube.
2 of them should be on YouTube and 1 of them's processing. It should be up within the next few days, but the first 2 are up there. So Women Who Code YouTube, if you search for the channel, you'll be able to find the Corda ones in there.
So I'll give another couple of minutes for you to finish the questionnaire. Please finish it because I really need your feedback.
I've just sent the link through again. Can you all see that one?
Yeah, because so far no one responded. It's anonymous. I'm not like he just wanted to understand if I explained it to you in comprehensive way. That's it.
I think it's just changing the chat to attendees rather than just panelists. That's all.
Okay. Thank
So
you.
I've sent it around now. It's all good.
Okay. Oh, I see. Okay. Thank you. So yeah, I'll give like another 5 minutes then. Thank you, Naomi.
No worries.
So yeah, I will give another couple of minutes since guys, if you can open the questionnaire that Naomi sent and fill it. I really need your feedback. So yeah, I will start in 1 minute. Guys, could you please finish off with the questionnaires? We really appreciate your feedback. So let's start. Next, next part of the exercise is by looking at the flow, by we issuing the state, by we create a transaction, and how we force Corda to store it on ledger, and at the same time off ledger, since our state was also implemented curable state. So curable state means that it will generate this mapped object and store off ledger in the custom schema as well. So let's in the issue product state flow. So we know flow. This is basically where we store our functionality. This flow is responsible of it consists of 4 sections. First, we need to create an output state that's called the product state. So we learn about transaction, and we know that if we want to issue or update a state, we need to do it via a transaction. So, but first we need to create all the elements, and then we put them all together into one chunk of a transaction builder, and then it will do everything for us automatically. So first we create this product state is our output. Then we create transaction by calling transaction builder class and specifying the output state, which we already created, and the parties that will sign this transaction. So in our case, it's only us who's signing it. So we put our own identity here, and then we also run the contract, which is a set of rules that has to be applied to make sure that this transaction is correct. So we run this contract by verify method. For now, let's keep, I keep the contract empty. So just every transaction has to run through the contract. But since we just, I don't want to go into the details of the contract, let's keep it simple. We just do it verify, and the verify has nothing in it. And then we need to sign it ourselves only. which is done by via get service service hub. So we learned previously that service hub give us access to all classes from the node, and also it allows us to sign our transactions through this function, and we put inside it, we pass our argument, our transaction argument, and then we need to initiate the flow. We initiate this transaction that creates communication with other parties, but since we don't have any other parties, we still need to initiate it. It's still like, I will go through it later on the next session, not today. And then this finality flow is the one that stores this data, our flow, our state in the on ledger. And
we do have one question that came in. Can I share that with you?
I see it. Okay, I see it. How is using scheme different from Vault query? So, so as I told before, Vault query is our ledger. So we store it on the ledger, but this is secured. There are many layers of security, and it's also stored in binary format, so you cannot query it. That's why if some of the fields that you store on your ledger, on the Vault, you need them, you need to store them and you need to query them, then you need to persist it off ledger. So this is the difference, that off ledger you can query it and you can see it's human readable format, while on ledger it's not human readable format. I will show you later on the example how we can the example when we run this code. And the entity manager, this is exactly, it will query our schema that is off ledger, and we will we have access to it again through service hub, and we call with entity manager, and then we run the lambda function where we create a query and then we run it. So on the first one we create a query and then we run it. Simple. And our last one is a Vault query. This is gives you opportunity to query the data. This flow, like, will query the data through the node, through the command line, right? So you don't need to go and see these blobs of binary data. You can run it through this command line. So let's see on the example. So I'm opening the terminal, and as usual, I'm deploying the nodes. Pascal, did you understand my answer, or you want me to go into it a bit more? So the Vault query is on ledger, and you cannot, the data stored there in binary format. You can see on the IDs, hashes, while schema, you can see the human readable format, you can read it. Now we run the nodes. Our node is started. So flow list provides you with all flows that are available on this node that I'm running, right? So I want to first issue state. I want to create it. and I run start issue flow. And since the constructor of issue flow requires one parameter, which is issue, this is like very helpful reminder if we forgot one of the parameters. So since we're on party B, how we know that we're on party B? It says here that this is for party B. Let's issue it to party A. So we see that result completed with the result like signed transaction and ID. So now, in case we want to query our Vault query flow, so we need to run this command. This is how we query it. And this is the result that we have. So in our issue state, we issued product with the following fields. So it's SKU name, test ID, detail ID, details, like all the fields that we that are in the product class. And here we see the result of some of those fields. Let's now query it with our entity manager. Let's query our off-ledger custom schema by running entity manager flow, and again start. And here it says that we need the following parameters. Since we know the SKU is 1 from here, and name is test1. So I forgot to put a semicolon. So we see the result, product details, SKU1 and name. It's on the ledger. So with the following example, we issued the state and created an on ledger and off ledger. Let's now go to the database and connect to our database. So this is our URL connection, and so we're using H2 console. We'll put a link on the H2 console where you can download it in our chat. So H2 console has so we go into binary folder, and then we run h2.sh. And we start our client, our database, and in JDBC URL, you put exactly the same line that is produced when you run the node. So this is line. This is the line that you want to put here. Then we connect to our database, and we have two, like we created off ledger table, which is a product. And let's see the table by running select star from product. So we have a table with one entry in it, which is name and SKU, and we also store transaction ID and output index. And let's see our vault states. This is our own ledger. This is our ledger. This is which is main functionality of Corda to store this information on ledger. And as you see, it has way more columns, like fields. And the last one, the data, is the binary data, the secure data that is stored here. So that's why it's not really like human readable format. But we also suggest you to use to query your vault, you query your ledger through the flow, not going here, because as you know, you can delete all the drop all the tables, and then you lose all the information. So this is just to show you, to demonstrate the example, how to demonstrate to the proof that we actually created two tables, one on ledger and one off ledger, with the main difference that on ledger is secure, is very secure way of storing your data, and it's stored in binary format. While if you need to query your data during your some business implementation of your logic, then you need to store your data off ledger via entity manager that we showed you today. So we need to have create one schema which is a subclass of mapped schema with all fields that you want to store in your custom schema. And there is also a product state, which is your normal state, but it has to be also implement with a queryable state to make sure that this state can be stored off ledger as well. So thank you so much for today. So this is the end of our session. Again, you can look for us on Corda.net. Please come and join Slack Corda.net. Or if you want to send any email, if you want to have a discussion, please go on Corda and find me, Iryna. Or you can email us by devrel@r3.com. Thank you so much.
Thank you so much, Iryna. Does anyone else have any other questions before we close everything off today? Well, if that's everything, then we'll let you all go. Thanks so much for joining us today. And I hope you join us for the next one as well.
Yes, please, guys, join us, and we'll later we'll provide you with a free Corda exam certification, Corda certification exam. Thank you. Bye, Naomi. Thank you.
Bye. Have a good weekend.
Bye. You too. Have a good weekend.